Hey, good morning, students. Let us see how to construct SR latches using NOR gates. First, let us understand what is a latch and what is the function of a latch. Then we will see about the SR latches. We know latches are used as a memory elements. They are used to store single bit information. So latch is a memory element that is used to store single bit information. It can store either 1 or 0. Okay, now we are going to construct this SR latch using NOR gates. Okay, in the previous video we have seen how to construct SR latch using NAND gates. Now we are going to see how to construct using NOR gates. Before getting into the topic, let us see the truth table of NOR gate. NOR is nothing but addition and a NOT. Okay, A plus B and a complement. Suppose A and B are 0, 0, 0 plus 0 is 0, 0 complement is 1. If it is 0, 0, 0 plus 0 is 0, 0 complement is 1. So this is the truth table of NOR gate. What is single line sentence or single line syntax of NOR gate? Output will be 0. Can you see the output will be 0 when any input is 1. If any of the input is 1, the output will be 0. That is the logic of NOR gate. You call it a single sentence of NOR gate. Any of the input is 1. Any of the input terminal is 1. The output is 0. Let us go at the designing part. So SR latch using NOR gates construction has 3 steps. First step, construct the circuit diagram. Second step, write the working of SR latch. Third step, put everything in a truth table. Okay, that is your third step. So let us start with the first step. It's a very easy thing. Let us start with the first step. We are going to construct what? SR latch. So there are two inputs, S input and R input. S input is called as set, R input is called as reset. We are going to construct it using what gate? NOR gate. So I am connecting S to a NOR gate and R to a NOR gate. Output of one gate. See the construction, how it is constructed. Output of one gate is given as an input of other gate. Output of one gate is given as an input of other gate. This is how it is connected. Clear? And you know, SR gate, SR latch has two inputs and two outputs. Output is Q and other output is Q bar. It is complement to each other. Here what is very important is this R and S terminals order is very important. Bottom is S, top is R. Clear? So bottom gate should be S, top gate should be R. First important point. Second point, the Q and Q bar should be complement to each other. Okay, if Q is 1, Q bar should be 0. If Q is 0, Q bar should be 1. So we have done the construction of SR latch. How we have constructed? We have taken two inputs, S and R. For two inputs, there are two outputs, Q and Q bar. We are constructing it with help of NOR gates. Output of one gate is given as the input of other. Output of one gate is given as the input of other or fed as the input of other. So let us, before seeing it, let us see the difference between latch and a flip-flop. You know, both are memory elements. Latch and flip-flop, both are memory elements used to store single bit information. But latch, if you see, the output changes whenever there is a change in the input. If the input changes, output changes. Whereas flip-flop, the output will change only if there is a change in the clock signal. So while we are getting into the flip-flops, we will understand what it is. But now I know I'm going to learn latch. Latch is a device whose output changes only when there is a change in input. Clear? Now we have done with the construction. So this is the construction of SR latch. Now we will see how it works. It works in this way. Before working, we need to write the truth table of SR latch. We know SR latch has two inputs, S input and R input. S input and R input. There are two outputs, Q and Q bar. Write the output Q and Q bar. Now we are going to do the working of SR latch for 4 cases. What are the 4 cases? 0, 0, 0 1 1 0 1 1. We need to build a truth table and tell what is if S and R are 0 0, what is the output? If S and R are 0 1, what is the output? That is what we are going to do now. Let us see the first case. What is my first case? First case is if S is 1, R is 0. Can you see if S is 1, this state S is 1, R is 0, what will be my Q1, Q bar? That is what we are going to see now. If S is 1, right, in the place of S, write 1. If R is 0, in the place of R, write 0. What will be your Q and Q bar? Let us identify this. We know these two gates are what gate? NOR gate. And we know the single line syntax for NOR gate. When any of the input is 1, output will be 0. So when any of the input is 1, now tell me which input is 1? Yes, input is 1. Since any one of the input is 1, what will be the output? Output will be 0. This is predicted output. From the truth table I am telling. Any one of the input is 1, output is 0. So what I am doing is I am sending that output 0 into input of other gate. So for this NOR gate now, there are two inputs 0 and the other input is 0 which is coming from the bottom NOT gate. So 0 and 0 is the input. If inputs are 0, 0, what is the output? Y is 1. So Q is 1. So my Q value is 1. So fill it. When S is 1, R is 0, what happens? My Q will become what? 1. Now let us check. Let us pass that 1 here and check whether this is right. If I pass that 1 here, what happens? 1 and 1. So what is 1 and 1? 1 and 1 is 0. So I have got the same output. So I know when S is 1, R is 0, my output Q becomes 1 and Q bar is 0. Fill the truth table. S is 1, R is 0, Q is 1, Q bar is 0. I am done with the first case. Now what is the next case I am going to do? Is when S is 0 and R is 0. What I am going to do? I am going to make my R as 0 as well as S as 0. Now what is my single line statement for NOR gate? When any input is 1. But here my both the inputs are 0 0. When I can work on this? Only when any of the input is 1. But here my case is when S is 0, R is 0. S is 0 and R is 0. What happens? I cannot do anything. So in this case, what I will do is whatever was there as a previous output. Can you see Q was 1 and Q bar was 0. Same thing I will get as the output when S is 0 and R is 0. The output is not changing. We are storing the same data as S is 0 and R is 0. That is why it acts like a memory. Okay, when S is 0, R is 0, it acts like a memory. Whatever was the output you had previously, the same output will come here. Okay, why? Because S and R are 0 and 0. Output will be 0 when any input is 1. Since there is both the inputs are not 1, you cannot predict it. So whatever was the answer of the previous state, the same state will be copied as such. Are we done with this? Now I know if it is S is 1 and R is 0, output is 1 and 0. If S and R both are zeros, my output acts like a memory. Now we will see the third case. See the third case. What is the third case? S is 0, R is 1. I made S as what? 0. I made R as what? 1. I know when any of the input is 1, what will be the output? 0. So any one of the input is 1. Can you see R is 1? So default what happens? Output will become what? 0. So Q is what? 0. Fill that Q as 0. Now pass that Q to S. So I get two inputs 0 and 0. When inputs are 0, 0, output will be 1. So Q bar has become 1. Okay, so Q and Q bar are complement to each other. So fill the truth table. When S is 0, R is 1. S is 0, R is 1. Output will be 0 and 1. What happens when S is 0, R is 0? Just now we have seen when both are zeros, whatever was there previously in Q and Q bar will come as such. Okay, that is why we call the state S is 0, R is 0 as what state? Memory state. What is the last case? This is my last case. When S is 1, R is 1. Oh my God. When R is 1, S is 1, what happens? I know when any of the input is high, when any of the input is high, output will be 0. Here, input is high, output is 0. Input is high, output is 0. Can ever Q is 0, Q bar is 0? Will this happen? This is the invalid state. What is the condition? If Q is 0, Q bar should be 1. Or Q is 1, Q bar should be 0. So when S is 1, R is 1, I get an invalid output. There is a violation in the condition. So I write here it as invalid. So what is the truth table of latch we have derived using NOR gates? When S and R are 0, 0, it acts like memory. When S is 0, 1, same output. Can you see? Input is 0, 1. Output is also same, 0, 1. When input is 1, 0, output also same, 1, 0. When input is 1, 1, it is a invalid state. So what is how that we are deriving in this case? We are constructing, first we need to write the circuit diagram for SR latch and tell how it has to be constructed. After telling it, you have to derive for 4 cases. What are the 4 cases? What happens when S and R are 0, 0, 0, 1, 1, 0 and 1, 1, and then fill the truth table. Okay, easily you can fill the truth table of SR latch using NOR gates. When S and R are 0, 0, it acts like memory, you know. When it is 0, 1, whatever input you have, same input right here as output. When it is 1, 0, whatever input you have, same input you write as output. You know, when it is 1, 1, it is an invalid case. So this is how we design and construct a SR latch using NOR gates. Thank you.